So, good morning, everyone. Is my voice audible?
Yes.
Yes, you're audible.
Great. So, we'll wait for 2 more minutes and we'll start the session. Thank you for joining. Is my screen visible?
Yes, it's visible.
Yeah, great. So, I have a few students joining. So, I'll start in about 1 minute. So, in today's session, we'll see basics of what an API is and how you can use it to do various design customizations inside of Fusion 360. So we'll walk you through some basics of API and a bit of Python programming, and we'll see the Fusion 360 document model. So if you have any questions, you can put it in the chat box, and in the last 10 minutes, I will be answering them. Feel free to drop your questions in the chat at any time during this session. And the session is being recorded, so it will be shared with you after it's over. So we'll see introduction to Fusion 360 Python API and how you can use the scripts and add-in function inside of Fusion 360. And I will also be sharing a few additional learning resources and what are the research areas that you can use or develop using the API. So why should you customize the CAD software? So every CAD software, just like Fusion 360, allow you to customize it using the API. So you see, these are some of the benefits, like you can customize the design and deliver it faster to the client. You can eliminate various modeling errors. You can check for modeling errors. You can make faster design modifications. And you can also develop and deploy artificial intelligent algorithms into the CAD design software. This is currently the emerging research area. Some of the researchers at Autodesk themselves are working on this. And we'll be seeing the artificial intelligent design algorithms evolving soon in the coming years. So API stands for Application Programming Interface. So every major software application comes with a API. For example, the regular applications we use like Microsoft Word, Excel, and PowerPoint have their own API, which run on Visual Basic for Applications, or VBA for short. And the WhatsApp we use has its own API, which runs with either Python or Node.js. And major CAD softwares like SolidWorks and CATIA also have their API, which run with .NET and C#, and they also support C++. And in today's session, we'll be seeing the Fusion 360 API using Python. You can also use C++, but we'll be more focusing on Python because it has certain advantages over C++. Like there are various machine learning and deep learning libraries available. And also Python is free to use. So how to get started with the Fusion 360 API? You need three basic things. One is the Autodesk Fusion 360. You can get it for free if you are a student or a faculty. So you can download from the Autodesk website and you can sign up using your email ID. And you need Python. So the latest version of Python is Python 3.1, 3.11. So it is currently supported in both Windows 10 and Windows 11. And it's free and open source. You can download it. And you can use any IDE to write Python code. And one of the popular IDEs is Visual Studio Code, which is also free and open source. So at the end of the session, I will be sharing this PPT. So you can simply click on these links and from there you can download Python and install it. I have already installed on my machine. So I'll be showing you how you can write Python code and then integrate it with Fusion 360 API. So, and coming to the official API documentation, one aspect I want to highlight here is generally there are very limited tutorials available because this is a completely software oriented and proprietary interface, which mainly used by Autodesk themselves. And it's not generally open for everyone, but if you know the procedure, you can also develop applications on behalf of Autodesk and host them inside of Fusion 360 or any other application. So the main way to get into software development is by reading the official documentation. You can get it from this URL. So I will also share how you can use the documentation to understand various aspects of programming and how you can search and you can get what you need. And there is one YouTube channel, which is the Python hackathon for Fusion 360. That's available on this link. I will share it in the chat box at the end. So you can watch that as well. And finally, this is the Fusion 360 object-oriented programming model. So this PDF is available on the documentation page. So it looks very complicated, hence I have simplified it to show a small demo for you. So basically what this is basically the document object model. If you have heard of object-oriented programming before, basically every function and a method will be run with objects, classes, and its methods. So in order to access each function inside of this Python API, you should know how in which tree each function is available. For example, there is something known as Autodesk App Core, and that's divided into document, and on that you have an active product, and then you have the design, and then you have the root component. And again, root component has 4 branches, one for construction points, another one is for construction planes, and third one is for sketches, and fourth one is for features. So we will be using mainly these, what I have shown. This is the simplified version of the object model. So I will also explain what are these arrows mean shortly. So basically, I'll quickly show you a small demo. So this is a cylinder that's created using Python. So in order to begin yourself programming, you should know how a typical model is built. In any CAD software, you first select a particular plane and draw the sketch. And after that, you stop the sketch And then you use various modeling features like extrude, revolve, sweep, cut, etc. to build 3D features. For example, in this case, you can draw a circle and then extrude it to get a cylinder. And in the model design tree, you can see that there is a sketch that's drawn on the XY plane. And then there is a cylinder that's being extruded using the extrude feature. So you can do the same thing inside of Python API. So first what we'll do is we'll select a certain plane and then tell the computer to draw a circle on that plane. And we'll also specify it with what radius and with what center point the circle has to be drawn. And then we'll also specify that particular sketch as the profile to extrude it. And we'll also specify how much height the cylinder has to be extruded. So that's how the Python API works inside of Fusion. So I'll show you a small demo. So you can see that the design is completely empty here. So now what you can do is you can go to utilities. And then inside utility, you can go to add-ins. And inside add-ins, you have scripts and add-ins inside of Fusion. Click on that. There are some predefined Python and C++ codes available. You can try them. And for the purpose of this webinar, I have created this code. And you can select that and click on run. And you can see that the system has automatically created this solid. And you can simply save this design and you can export it and do whatever the stuff you like it with it. Similar to how you do in your regular CAD design. So how you develop the Python code, I'll show you the process here. So this is basically the Python code that enables you to draw a circle and then extrude it. At the first time, if you are completely new to programming, this may look a bit scary. But if you understand the logic, it is very easy for you to develop applications using Python. So basically, there are 3 steps being involved. One is to create a Fusion 360 document and assigning a root component. So if I come back to Fusion here, you can see there is a root component that is attached. This is known as the root component. And inside the root component, you have an origin and you have the default XYZ planes. And to that particular root component, you have a body and you have a sketch attached to it. So exactly the same thing you can find in the Fusion 360 Python as well. So basically this lines of code tells that you have to create a Fusion 360 document, that is app.documents.add. So I will share the code with you so that you can play around with it. For now, don't worry about, and no, you don't need to remember all of this code. You just give an introduction to how the code works, and then we can go more deeply in some other session. But here, basically what is happening is you are assigning that design to a root component, and you are accessing that root component to generate sketches and then to generate various features. If you come back to the previous slide, once you generate the root component has various objects within it. One is the sketch object, and there is a feature object, and there is a construction plane object, and then there is construction point object. So here, so root component dot sketches will call a function and create a new sketch. You are saving that under the sketches, and then using that sketches object to add a new sketch. And we are calling it as XG construction plane. So that particular construction plane will be assigned to this particular sketch. And then it will be saved in the variable known as sketch1. And then you are creating an origin point to draw the circle. So the center point, you are giving a variable name, and then you are using the point 3D function to create a point at the location 0, 0, 0. That will be stayed in center point variable. And then you are calling the circle 1. That is sketch1 dot sketch curves dot sketch circles dot add by center radius. This is nothing but the nesting of each and every function inside of Fusion 360 Python. So here you have sketch curves method. Inside sketch curves, you have sketch circle, and inside the sketch circles, you have add by center radius. So inside that, you are creating the circle one, and that is going to be saved as item number 0. That's what is happening here. Each and every sketch you draw will be assigned to a particular profile. So profile is a list containing various items. So the first sketch is going to be assigned to item of 0. That's an array or a list, you can consider it. And then you are creating an extruded body by again calling the root component dot features dot extrude features. So again, you come back to this model. You can see that in root component, the 4th row is for features. It contains extrudes, revolves, and various other modeling features. So inside that, for the purpose of this demo, I'm showing only extrudes, but there are various objects here. I can try and show it. This PDF is available from Autodesk website. You can just have a look. So basically, this is the application, and then you have user interface, and then you have documents. So inside the documents, if you go down, you can see there is a component. This is nothing but your root component. And then inside root component, you have features. And then each feature has a base feature, boundary fill, box, chamfer, circular pattern. All of these are methods which are mentioned here. So in order to access them, you need to create a root component first, and then using those functions, you can create these various features. And in the next root, you can see that various whole features are being shown here. And then if you scroll a little bit, you can see mesh bodies. If you are working with meshes, you can use various mesh-based functions. And then if you scroll down, you can see various joints and sketches. So if you are building an assembly, you can use the various joint functions here. And then inside sketches, you can see profile, sketch curves, and inside sketch curves, you can see sketch ellipses, sketch circles, sketch arcs, sketch splines, sketch lines. These are all individual methods or functions that are available inside of sketches. So I will share this PDF with you all via email so that you can explore. And for the purpose of this demo, I am showing a simplified version of this tree here so that you will understand it more better. And coming to the next slide, finally, we are creating a feature called extrude feature and giving it as a variable name. And then create by real will assign a particular value to it. And if you are giving a value of 5, it is going to extrude by 5 centimeters. And the important thing you need to remember is this API runs by taking centimeters as the default value. So if you are specifying 0, 0, it's basically is in centimeters. And here you have created a center point, and then you have given 5.0. This is nothing but the radius of the circle, that's 5 centimeters. And similarly, you have saved a variable called distance by calling the autodesk.core.valueinput.createByReal function. And for the extrude feature function, you are calling the add by simple function again. And here you can see that you are sending the profile one, which you have created earlier. That particular profile is sent to this function, and then the value of distance is sent, and then you are specifying it as a new body. So if you have used Fusion 360 before, you can either join and extrude to a previous body, or you can also create it as a new body. So for creating new body, this is the particular argument you send to this function. And finally, you are assigning it to body one. So body one will be containing this particular body, and item 0 indicates that it is the first element in the body list. So now I will take you to the complete Python code. So this is how the overall Python code looks like. I will be sharing this with you after the webinar. So if you have this presentation alongside with you, and if you look for each and every line in this particular Python code, you will have a better understanding of what is happening. So basically, you are defining a function called run, and you are giving it in the try. So if there is any error, you can catch the exception and you can say that the function has failed. So this is an exception handling which is available in Python. And you are checking whether the state of the extrusion is good or not by using the health variable. And if there is anything wrong, you are displaying it as an error message. And you can see that body one equal to extrude one dot bodies. This is what we have seen in the earlier slide. So that's the particular line here. And you can see that here profile is equal to sketch dot profiles dot item is 0. This is the sketch or the circle which we have created earlier. And you can see here what's the radius. So if I change the value here, let's say I will give 10 centimeters as the radius, and then 1 centimeter as the extrude height. And now I will save this Python file. This is the Visual Studio Code. You can run and save Python files here. And now you can come back to Fusion, open a new file or a new design, go to Utilities tab, and then click on Add-ins, and then go to Scripts and Add-ins. And now you can click on this Python file and click on Run. And now you can see the radius of the cylinder is increased by 10 units and the extrude height is only 1 centimeter. So if you want to verify the dimensions, you can simply go to Inspect and Measure. And if you select these two faces, it is going to give you the value of 10 mm, which is nothing but 1 centimeter. And if you select the diameter, it's going to give you the radius of 100 mm. That's nothing but the radius which we have given. So that's the introduction of how you can use Python API inside of Fusion. So there are various inbuilt Python functions. You can again go to Utilities and Add-ins. So Fusion 360 gives you some predefined Python codes, for example, Spurgeon, pipe, intersections. So if you click on Run, you can see that. Please be on mute. Anyone is speaking? So this is the inbuilt function for Spurgeon inside of Fusion. You can also create such user input snippets. So you can select whether it is the metric. You can select the pressure angle of the gear. And after giving all these values, if you click on OK, it is going to generate a gear. So you can see that this is way more powerful than individually creating each gear tooth and then creating the sketch and then extruding it and then giving it a pattern. So you can develop such powerful applications if you know a bit of programming. And now if you have learned a bit basics of artificial intelligence algorithms, you can deploy them so that you just input a feature vector and that feature vector will compute which particular sketch has to generate. Let's say 0 stands for a circle and 1 stands for a square and 2 stands for an ellipse. So like that, you can encode it using an autoencoder. And then you can develop a Python code and you can simply run it so that you can generate more complicated designs inside of Fusion. So if you have any questions, you can ask. You can unmute yourself and you can ask. And I've got a question in the chat. Except Python, which other languages are used by different companies? So generally, companies are using Python, JavaScript, C#, .NET. So basically, if Windows-based applications are developed in C# and .NET, and web applications are developed in JavaScript. And Python is a general purpose language, which is getting more popular because it's open source, and various machine learning and deep learning frameworks like TensorFlow and PyTorch are available inside of Python. So as far as Fusion 360 is concerned, both Python and C++ are active. And like I said in the beginning of the presentation, so if you want to customize the same thing using SolidWorks or CATIA, you can use C++ or you can use C#. And you can learn Fusion 360 from YouTube. There are good YouTube channels. And you can also read the Fusion 360 official documentation to learn it. And if you are really interested, we can create more sessions on basics of learning Fusion 360. So if you show interest, then I will be conducting Fusion 360 courses for you also. And if you have any questions, feel free to ask. And coming to the research areas, currently artificial intelligent algorithms for 3D CAD design, generative design, topology optimization, and then creating the various manufacturing constraints inside of Fusion 360. That's the research area. And if you are really good in Python programming, you can apply for a design development role inside of Autodesk. So that will be really great. And you can also land into an internship at Autodesk as well. There is something known as Fusion Catalyst internship in Autodesk. So you can apply for it and you can do your internship in Autodesk. And if you perform well, they will be able to absorb you into a relevant role inside of Autodesk. So that's the power of having a little bit of programming knowledge and having a little bit of understanding on CAD design softwares. So I will share this presentation, I will share this code, and I will also share the document object model. And I will show you how the official documentation looks like. So this is the official documentation. You can see on the left-hand side, there are various help files. So inside you have to go to programming interface. And here you can see Fusion 360 APIs user manual. And inside user manual, you have various Python specific issues and C++ specific issues. So if you again scroll and go down, you have the API reference manual. And if you expand this, you see various objects. So these are the various objects available with which you can create the functions. So previously we have seen the sketch object, extrude object. So they will be available here for you to read how it works. So you can see that extrude feature is there here. So if you click on that, You can see how this function works, what is its class type, and what are its properties. Everything will be available here. And if you need some demos, some demo programs are also available. You can go to sample programs here and you can see geometry creation. And inside geometry, you have boss feature sample. If you click on any such sample, you can see what is the Python code. You can simply copy this code into your Visual Studio Code. Click on add a new function, name it demo2.py, and inside that you simply paste it, save the file, go to Fusion, create a new file, again go to utilities, so each time you need to create a new folder. You can go to create, click on Python, give it a name, and give the folder location. Select that, click on create, and you have a demo2. Click on edit. And you can paste the code. And save it. And now you can see demo2 is right here. Click on run. It is asking to select a sketch point. So depending on the function, you can try one more function. We'll try this one. You copy it. And you can see that particular base feature is created. You can simply click on finish the base feature. So like that, you can explore various inbuilt examples. And if you have any questions, you can put in the chat box. And we can wind up the session in 5 minutes. So if you don't have access to Fusion 360 software, you can send me an email I will leave my mail ID here. So if you want a Fusion 360 license, I have limited licenses, but I will try to make sure that you get it so that you can start learning. So if you are a student, you can simply sign up using the Autodesk account. If you are working somewhere, but still if you want to learn Fusion, you can either sign up for a freelance, that is hobbyist license, or if it is for the purpose of learning, then I will be able to send you the license for 3 months, which you can use for your learning. So I'm leaving my mail ID here in the chat. You can mail me any specific questions you have with Fusion 360 or with Python programming. Feel free to reach me out. And I will be sharing the feedback form on your email. Please fill that, and for this, you will be getting a certificate. Yes, this meeting is recorded, so I will share the video file as well. So thank you for joining then. We'll wind up today's session, and I will be sharing the feedback form. Please fill it if you want a certificate. You can leave the meeting now. Thank you very much. Thank you for your time. Thank you for joining.